Hello, this is day one of lesson 7.1, which is inverse trig functions. Now, before we talk about the lesson itself, there's two things I want us to review about inverses to begin with. And the first is finding an angle. And when we're finding an angle, we know we need to find the relationship of the sides to that angle. So this is opposite, this is hypotenuse. So OH is sine of the angle equals 11 over 18. So when we do this, we are looking for the inverse. So we use the inverse sine to find the angle. Using a calculator, I'm going to use the second button. Okay, and then this is 37.6699 degrees. Okay. So when we're finding using an inverse trig function, we're looking for an angle. That's one thing that we have to remember. Let's go back and talk about inverses graphically. So if a function is 1 to 1, okay, so for an equation or graph to be a function, it has to pass the vertical line test, right? Hits a vertical line only in one place. Great. Blue one, totally worked, which is e to the x. But to be 1 to 1, you have to pass also the horizontal line test. So horizontally can only intersect in one place. So if it is a function and it is 1 to 1, for every x there's only one y, and for every y there's only one x, then you can take the inverse. So the inverse here is the natural log. So e to the x and natural log of x are inverses. If we're looking across this line here, right, the reflection of the exponential over this line, y equals x. The slope is 1, the intercept is 0. You would get this. That's a nice reflection over it, right? So for inverse functions, remember, we're looking for the angle, and for inverses, it needs to be 1 to 1. So it reflects over this line. So let's think about sine and cosine. Well, they're functions, right? They pass the vertical line test, but are they 1 to 1? Do they pass the horizontal line test? So if we're looking at here, let's draw a horizontal line through. Does it hit it in more than one place? And it does, so that fails. So this is not 1 to 1. Well, what about a cosine? Well, another horizontal line. Nope, fail. All right. But clearly we do talk about inverse trig functions, but they're not 1 to 1. Well, let's look. So here's our sine graph, sine x. Okay? And here's that line that we reflect for inverses. Let's see what happens if we do reflect this curve. Okay, so take a moment in your head. So what do you think this would do if I reflected over this line? Well, I think this part here is going to go on this side, and this part here should go on that side. Let's look what happens. Wow, well, that's kind of like wacky, right? It's true. So this part did go this way, and this part went down. So is that a function, that wave curvy reflection? No, it's not a reflection. Why not? I mean, it's not a function. Why not? That's right, it doesn't pass the vertical line test. So is there a way to make it a function? So not a function. Let's see. What if we restrict it? What if we don't do the whole thing? Like parabolas, right? We know a parabola x squared. When I take the inverse of that, we take the square root. But the square root, if I try to reflect that, it would be a u, and that doesn't work, right? That's not a function. But when the square root, we know that square roots can only be positive, so we restrict it, and we only do this top part for the inverse of a square. So we can do something like that with sine graph, right? So we're going to restrict it to here. So instead of doing that whole part, and remember it kept going like that, and this like this, they're just restricting it to here, to here. And when we do the inverse, we're going to change the x and y scale. So we're only taking one small part of it before it flips over and then it's no longer a function. All right, so this is inverse sine. Here's my equation. Remember that -1 means inverse. So if we're looking at the domain, which is the x value, it's -1 to 1 inclusive. The range is now an angle. Remember at the beginning, when you find the inverse of a trig function, the answer is an angle. And we write it in radians. Okay. The x-intercept and the y-intercept are both the same, 0, 0. Now the quadrants means this. So in your answer for when you're doing this, you're only going to have one answer. This is different than solving an equation. So because of it, we're looking at the range. One answer. You're going to have a positive area and a negative area. So for here, if you're looking at the quadrant, right, on the unit circle, negative pi over 2 to pi over 2 is here, right? So if it's positive, the answer is going to be in the first quadrant, and it's negative, it's going to be in the fourth quadrant. So positive is the first, and negative is in the fourth. So this area from here to here represents the first quadrant. Right? From 0 to pi over 2, which is 0 to pi over 2. And this part represents the fourth quadrant. Right? From 0 to negative pi over 2. We will need this later, and I'm going to be drawing this often, but they're not the same for all of the trig functions. Also remember sine is odd, and it comes from that as well. All right, so let's look at cosine, starting up at 1. Here's our line y equals x. What would it look like if you reflect it? Again, this would go up, this would go down. All right, and there it is. So is a green a function? No. Doesn't pass a vertical line test. Fails vertical. I think I spelled that wrong. Vertical line test. So is there a way to make it a function? Yes, we're going to restrict it. Now when we restrict it, you can see it's different. This is completely above the x-axis because cosine is an even function. So here we are. right? So domain goes from 1 to -1, or -1 to 1, sorry. Smaller number always first, left to right. Range, we're going from 0 to pi, inclusive. The x-intercept is 1, 0. Y-intercept is 0 pi over 2. All right, so for cosine, our range is 0 to pi. So if we look over here, 0 to pi over here on the unit circle, pi over 2 is here. So cosine is positive in the first quadrant. So it's positive here and negative here. First, second. That's there, right there. Okay. So from 0 to pi over 2, 0 from pi over 2, it's positive. And then from pi over 2 to pi, it's negative. It means it's going to give you a negative value. Cosine is negative in the second quadrant. Let me double check here. Okay, I forgot to put plus, minus. So you can see that cosine is different than sine. Sine is first and fourth. Cosine is first and second. So it's positive in the first and negative in the second. All right, let's look at tangent. All right, so that one's even, okay, so that's going to be different. Totally reflects over. Okay, so you're like, wow. So you're looking over here, tangent x is the blue, and when you reflect it, you get the y's. So you can see that the blues go vertically, right? So when you reflect it, it's going to go horizontal. Kind of interesting. So are the reds a function? No, right? Fails the vertical line test again. Fail. Right? Hits it in 2 places. So how can I make it a function? Well, again, we restrict it. And this is similar to sine. So tangent is also an odd function. Right, so the domain, you can see that it's going on forever, right? In this direction and that direction. So it's all real numbers, so it's parentheses, not equal to. The range, here, so you can see that it is approaching negative pi over 2 and pi over 2. The x-intercept is 0, 0, which is the same thing as y. Now, the range for tangent is similar to cosine. I'm sorry, similar to sine. Okay. So it's between negative pi over 2 and pi over 2. But not inclusive. So here it's positive and there it's negative. So from here to here, it's going to be in the negative quadrant. I mean negative, so it's going to be in the 4th quadrant. And positive in the 1st quadrant, which is from here to here. All right, so let's actually do some problems. Now, when you're looking at the directions, these are, oh, sorry, the -1 didn't come out. These are different than solving equations. There's no x, right? You don't see a theta. So this is only going to have one answer. So this is not the same as this. Let me see. That is not the same as this. This will have multiple answers. This is only going to have one answer. This is multiple answers, possibly. This is going to have one. Okay. All right, so cosine of root 3 over 2, that's positive. All right, so that's going to be in the first quadrant. Okay, and remember, we're going to draw first quadrant. Cosine is root 3 over 2 is here. It's 1, that tells me half. Remember, our question is, what is that angle? And that angle is 30. And yes, class, please write it in radians. Pi over 6. That's it. All right. So sine. Now, sine, remember, it's either in the first or fourth quadrant. First is positive, fourth is negative. So sine is negative, so it's going to be in the fourth quadrant. And negative half is here. So what angle is going to get me that? Well, that's going to get me 30. Now, because it's negative and we're in radians, it has to be a negative answer. So we're going this way. So it's going to be negative pi over 6. I'm going to say that again. Do you remember earlier we said that the range, the answer has to be from here to here. And negative pi over 6 is there. Now, if you're just like, but Miss Mendoza, what about this? What if I want to say 11 pi over 6? Isn't that the same angle? It'll get you the same answer. However, remember our range for the inverse. You can only have one answer. Is 11 pi over 6 in between here? No, it's not. It has to be between here. That's the range. So that's our answer. All right, tangent. All right, tangent of 1. Okay, so tangent is in the first or fourth quadrant, and it's positive, so it's in the first. So it's 1, that means these two are the same, and the only one that it's the same is 45. That's going to be pi over 4. Some of you may have just memorized that, and that's fine. That's great. I'm glad you have. Make your life easier. All right. Sine negative 1. Okay. So it's negative 1. And remember, it has to be negative pi over 2. Negative pi over 2 to pi over 2. So negative 1, that's a special one, because it's opposite over adjacent. And I can't have negative 1 over 1 as a triangle. That doesn't work. So it must be one of these. Okay. So over here, you can see the negative 1's here, so that's going to be negative pi over 2. All right. Practice on your own class. Don't forget, ask yourself, what's a restriction? And each one has its own restriction. Remember, cosine is from 0 to pi, and sine is from negative pi over 2 to pi over 2. All right. Thanks for watching. Bye.